Hi, everybody. Welcome to the Azure Data Academy, our follow-up session from our Azure Database for Postgres Flexible Server session. In this one, we're going to dive a little bit deeper into using Postgres extensions in Azure. I'm your host, Brian Hitney, a CSA focused on data and analytics, and our expert is Gennady Kostinsky, Senior PM on the Azure DB engineering team, who has graciously offered to come back to dive into Postgres extensions. As an overview, if you're new, our Data Academy, which is at aka.ms/ADA, our data-centric presentations, we're going to cover everything from SQL Server, MySQL, Postgres, Cosmos DB, very similar to our Modern Analytics Academy series, which is at aka.ms/MAA. You can find this and all of our other content in our repo at aka.ms/partner readiness, and we welcome your feedback. So if you have other sessions you'd like to see or comments on this session, let us know. You could give feedback directly through our GitHub repo or through our office form, which is aka.ms/ADA feedback. Without further ado, I'll turn it right over to Gennady. Gennady, it's all yours.
Thanks, sir. And my name is Gennady Kostinsky. I'm a senior PM in Azure PostgreSQL team. You might know. Today we're going to look at PostgreSQL extensions and what are they, what do they do, how to work with them, and how they're an important part of Postgres that make it more than just a relational database, but what people call an object relational database. So that's an agenda today. I kind of already stated. We're going to look at extensions, categories, how they're supported, how the developers create extensions, some of the most popular extensions, things with Postgres, and how we support them in our PaaS offering as a flexible server, Azure. Well, the real big name is Azure Database for PostgreSQL Flexible Server. So let's talk about extensions. So the idea is that Postgres is unique. So there's a idea of a plugin called extensions that can be plugged into the engine. And starting version 9.1, these extensions could override your typical database module behavior, like your engine default behavior. And then when you use the syntax called create extension with extension name, you essentially download an extension, install it, and then you install it inside the engine or plug it inside the engine by doing create extension name. It dynamically loads that extension into the Postgres address space. So they're running in process to Postgres. In a lot of ways, that's great because the performance overhead of an extension is great. It's very small because they're running within Postgres address space. But it also makes them a bit, as you understand, a bit dangerous because if their extension is not correctly written or has an error or some sort of an issue, it can actually take down the Postgres itself. So Postgres, that's the beauty of it. That's why people call it object relational database. Like it's really, really extendable. Not just what can you extend with it, but writing your own functionality. Well, you can build your own type system and your own operators. You can do user-defined functions and aggregates. You can extend the storage system and some indexing. We'll talk about it. Write-ahead logging, which is what people in other operating systems call, or other databases call transaction logging and indexing. Replication, transaction engines, background worker processes, query planner. So it's obviously possible to write an extension that changes the way that the query plan is interpreted or queries execution is done. Configuration, database metadata. So there's thousands right now of extensions. These are usually created and maintained by community. You'll find all kinds of repositories in GitHub. And these extensions, some of them actually change the product quite a bit. So Postgres can become a completely different database in a way its behavior is just by installing the plugin extension. So how do folks develop these extensions? Well, first they kind of develop the code, they debug it, they test it within the Postgres, they package it, and then they release it on GitHub. So that's kind of your typical extension development lifecycle. Of course, a lot of these extensions become very popular, in which case there's versioning introduced, minor and major versioning, and some of the major versions align to major versions of Postgres. So, give an example. Even though majority of the extensions are backward compatible, some of the extensions like timescale, let's say, the newer versions of it don't work with the older versions of Postgres and so on. So it's important to look at versioning as well. So where and how and what and how do you categorize these extensions? So the extensions come in particular categories. As I said, there are extensions that are so popular and so well known, they essentially are shipped together with Postgres. They're called contrib extensions or contributor extensions. And these extensions are developed and shipped with versions of Postgres. So as you get a new version of Postgres, you get a new version of an extension in a contrib folder with it under contrib directory. So obviously these extensions are a lot easier and a lot safer to implement because they get tested together with a new version by community. So as the new version of Postgres comes in, these contrib extensions get tested with it. So it's the same kind of a life cycle that Postgres has. So it's a lot easier to kind of keep track of them, test them, and I'm sure they're a lot more safer and secure as well. Then there's custom extensions, not to say that these are not safe, but they're developed independently by developers. And these extensions are installed independently of Postgres. So the Postgres doesn't come with them. And they can be installed independently and then loaded with create extension and then pretty much ran. But the versioning there is not coinciding with the versioning of PostgreSQL. So major versions of the extensions can come independent of PostgreSQL version. There's a couple of ways. So you kind of take these custom extensions, drop them on a box, you do a make install or make, and then the required files are copied to particular to an installation directory, and then you just run create extension, which loads that extension into PostgreSQL. There's a couple of files that every extension typically has. There's SQL and control files. Once you install it, that are placed in shared extension directory under Postgres. And there's a DLL files that have to be placed in a lib directory because, as we stated, these extensions run in process. So these are dynamic link libraries that run in process. All right, a typical custom extension example, not the one that's placed under contrib, is a pgcron, for example. So number of products like SQL Server has a task scheduler built into them. Postgres does not have a task scheduler, but you do need to schedule maintenance, other tasks, with the database. For that, Citus, which is a separate company at one point that actually Microsoft purchased later, created an extension called pgcron. And essentially that is an extension that kind of mimics the cron, which is the task scheduler in Linux, only it runs inside Postgres and can schedule Postgres jobs within the databases. It's open source, and it's pretty simple to schedule things right inside a database with SQL statements, as you can see in examples. Like to run a vacuum in Postgres every day at 10, you just use the cron schedule function and kind of provide the parameters, time parameters, and a date parameters, and run it. Other popular extensions include timescale DB. It just tells you how extensions can make your typical, what you would say, a relational database. That's why we call it Postgres object relational database, behaving very differently. Timescale is the Postgres for time series. So it's built to run time series type of workloads. and to store time series data, right? Which is not very easy to store in your typical relational database. Um, PostGIS, another type of data that's not easy to store in a relational database, which is geographic objects, and trying to kind of grab location data. That's not easy in a relational database. That's why the PostGIS makes it easy to store such spatial data. Another interesting one is ZomboDB. We have customers use it. For example, that mimics more of a kind of a textual search in Postgres, sort of like Elastic. It actually uses Elastic um, under the covers, once you install it, to kind of bring in all the powerful text search and analytics indexing into Postgres. Postgres foreign data wrappers, there's a gazillion of these. You have Postgres FDW, Oracle FDW, and such. This, T-SQL FDW, I mean, there's a gazillion of them. The foreign data wrappers, what they allow you is to access tables on a remote database servers. For Postgres FDW, that's Postgres. For Oracle FDW, that's Oracle, and kind of essentially query these remote servers in kind of a data virtualization way. So you can use Postgres sort of a front end to these backend databases. So there's lots of popular extensions. These are just some of the most popular ones that allow you kind of do more than your regular relational database can do. In a flexible server today, we support 45 extensions. Obviously, the contributor extensions, we support all of them. As far as third-party extensions, we don't support all the third-party extensions because there are some so-called unsafe language extensions that one cannot support in a PaaS environment, right? Now, these extensions run, as I said, in process. So we kind of reserve our right to kind of debug them for customers, and we find some issues. We reserve the right as part of the support to ask customers to uninstall these extensions, obviously, if they're not safe for one reason or another. But we also work with extension publishers and the community to test them and to make sure that they're safe. And if we find something, we definitely report it to extension publisher as well. So currently, a user can see available extensions by simply running show Azure extensions in the Azure Flexible Server, Postgres Flexible Server, and we'll show you a large extension string that will kind of explain, show you every extension that you can install. For security reasons, for some of the financial customers, we allowed kind of a feature that you have to allow list the extension before you can use it. So right now, I'm just going to show you, how you allow list and use an extension inside, our PaaS offering, Azure Database for PostgreSQL. So here I have a server, which is a Postgres PaaS server. And what I'm going to do is I'm going to go and find a PostGIS extension and allow list it. Just going to go find extensions. Here's like Azure extensions parameter in my parameters. And I'm going to find a PostGIS extension, which is, if you remember, the extension that allows me to use spatial data inside a database. So I'm going to kind of take all these PostGIS extensions and allow them. And then just save my results. While I'm doing that, I am going to go to pgadmin. And I already logged into this database before. So what I'm going to do is I'm going to create this extension. Now that I allow listed this extension, I can do it easily. All right. The extensions are created. I mean, I might as well create all of them, but I don't need all of them really. I just need the PostGIS. Now I'm going to create a table which holds the geometry data types, which is what PostGIS is all about. It's all about, storing spatial columns. That's it. Create an index, which is also, you notice it's using gist, which is something the PostGIS allows me to do. Insert a record in there. I don't know much to insert, but I'm inserting a 0.00. I mean, there's not much to insert there. So, but the idea is that it's inserted. And then, now I can select this record using within function. So I'm saying, find me something within this record within 0.00. So if the PostGIS wouldn't be here, this obviously would not come back quickly like this, or would not even be available. So that's the whole idea, that within a few minutes, I can now, I can now go in and create, turn my typical relational database into what essentially is a spatial database. So that's kind of where we, for a quick demo. So hopefully this is just the beginning of your extension journey. Hopefully you can look at the extensions as you need them. Look at timescale, look at pgstat, look at a lot of those popular extensions that I mentioned, and experiment with those as, if you're an app dev folks, it will allow you to use Postgres in some new and innovative ways for your applications. Thank you.
Thank you, Kanadi. That's great information. Thank you, everybody, for attending today's presentation. Once again, you can find our content, aka.ms/ADA, and your feedback is most appreciated, which you can leave directly in our repo or through our feedback form, aka.ms/ADA-feedback. Thanks again for attending, and we look forward to seeing you in the next session.